All right, we're going to go ahead and do shifting functions, which is Algebra 2 Semester 1, Unit 4. And actually, we're going to kind of cover a couple different topics, 4.2, 4.3, 4.4, I believe. The first one is talking about parent functions. So what they give you in your study, guys, they give you 4 parent functions. See if I can remember them. All right, so have these typed in. So the first parent function is the linear equation. So y equals x. It's just a straight line goes through the origin. So every line that we have is some change of this. If I want it to go a different direction, I go ahead and I make it negative. If I want it to move, I just add or subtract something, whatever it may be. So, but everything's based upon the parent function, right? Just like children have characteristics of their parents, they have the genetics shared, blah, blah, blah. Same thing here with y equals x. Everything, everywhere we move a line, any line is going to be somehow different from y of x. It's going to start here and then shift some way. Same thing with the quadratic equation. This is the default. This is where it starts, and then we can shift it. We can stretch it if we want to. We can go left and right, and we'll talk about how all this works here in just a minute or so. Boom. So these are the parent functions. Again, the parent function is just where you're starting. Now, this one is the absolute value. It normally looks like this. It's that. Y equals the straight line's absolute value. I just don't believe that Desmos recognizes it. I'll try it, I guess. I guess they do. So you could either type ABS or use the straight line, which is above the enter sign, at least on a Windows keyboard and a Mac keyboard. It looks like. I'm not sure about Chromebook. So you could type it in or do ABS. It's the exact same thing. It's just talking about the absolute value function. And then same idea. It starts at the origin. It's a straight line, forms a V, and then you can shift it, move it up and down, however you want to. This last one is the reciprocal function. So it looks like it kind of has two parabolas. It does not touch the origin, but the origin is kind of like the center. It kind of like is equidistant there. And then we can shift this however we want. So these are the parent functions, and then anytime you have something in any of these forms, it would all refer back to these parent functions. So that was a quick little hitter there. And then now we're going to go into shifting functions. The first thing they ask you to do is we're going to shift up and down. If we're shifting up and down, well, up and down is my y-axis. So if I want to shift up, it's easy as pie. All right, so I have x squared. If I want to shift it up, say I want to shift it up 7, I'm going to go ahead and do plus 7. Of course, now you can't see it, but there it is, plus 7. Excellent. Say I want to shift it down 5. I just, oh, forgot my equal sign. I just go ahead and add that minus 5. Get rid of the minus 5, it goes back. I put the minus 5 back in there, it shifts down. So whatever this number is outside, just kind of by itself at the end, it shifts up. Say I start with this red function. All right, cool. X squared plus 7. Here I am. Well, say I want to go down to here. I want to go down to 3. Well, I'm at 7. I want to go down to 3. So what I need to do is I need to subtract the 4. That brings me down, and well, 7 minus 4, I can just rewrite this as 3. It's the exact same graph. So if I'm going up and down, I'm just moving this number back here, whether it's obviously negatives down, positives up, and I just change that number and it will change up and down where it goes. All right, so that's one entire quiz. Ace it. Now, if I'm going left and right's a little bit different. Left and right, same general concept, I guess, but just a little bit different. So left and right is my x-axis, right? So now we're dealing with the x's. Well, where is my x? My x is over here with a squared. So, all right, cool. Let's say I want to shift to the right. All right, cool. I want to shift to the right too, plus 2. Oh, I went up. That's not good. Well, we didn't do anything different. We can't just add it at the end. We have to add it to the x. So what you actually do is you go ahead and put parentheses around your x, and notice how the x squared, the squared piece, the exponent is outside the parentheses. That's key. If I'm changing my horizontal, my x, my left and right, If I'm changing that, I have to put parentheses around the x with the squared behind, outside of it. Alright, now, if I want to go right, say I want to go right 3, should I add 3? That's what you're all going to think. We're going to go ahead and do a plus 3 here. Uh-oh, what happened? We went left. So what I just showed was that left and right is opposite. So up and down is normal. I add to go up. I subtract to go down. Um, easy peasy. If I'm going left and right, I'm actually doing opposite. So if I want to go right 3, I'm actually going to subtract 3. If I want to go left 4, I have to add 4, and it has to be within parentheses. Alright, so there, it's opposite. It is what it is. Don't need to worry about why. It just is what it is. If I'm going left, I'm going to go ahead and add. If I'm going right, I'm going to go ahead and subtract. Alright, it's that easy, but it has to be within parentheses, and the exponent has to be outside the parentheses. So your adding or subtracting is inside, your exponent's outside. Alright, now the last thing that we'll talk about a little bit is vertical stretch and horizontal compression. So if I want to do a stretch, if I'm stretching something, I'm going to make it skinnier, make it kind of longer and taller maybe. I'm stretching it out. So if I want to stretch it by a factor of 4, well, not 34, but if I put 3 in there instead, I just multiply by 3. So there I am, I'm just multiplying by 3. Say I want to compress, I want to make it smaller. I do 1/3 and it gets wider. So I have my purple function, which is my parent function. My blue is then compressed, it's outside. And then I'll go ahead and do stretch. Stretched is inside, so it gets smaller. So if I'm getting stretched, I'm going to be inside a parent function. If I'm getting compressed, I'm going to be outside a parent function. I'm going to be wider. Compressed is wider. Vertically compressed is going to be wider. Vertically stretched is going to be skinnier. Now, just for fun, I'm going to go ahead and do something different. I want to stretch by a multiple of 5. I want to shift down 7. And I want to shift left, we'll say left by 3. Alright. Stretch by a multiple of 5. And then I want to flip over the x-axis. Excellent. So I'm flipping over the x-axis. So, first thing I want to do is I want to stretch by a multiple of 5. So what I'll do, boom, I put a 5 there. So now I've stretched by a multiple of 5. I now want to shift down 7, minus 7. I just shifted down 7. I want to shift left 3. I gotta put my parentheses in. And then I'm going left, so I'm adding 3. I went left. Now I want to flip over the x-axis. How do I do that? We haven't talked about that. How do I flip over the x-axis? It's as easy as I go in front, go to the very beginning, and I'm just going to put in a negative sign, and it flips over the x-axis. So I just went through all that nice, simple, quick.